So, hi, welcome back again to my channel. So, by the way, I'm Gutierrez Donald A. And for today's video, I'm going to make a video that OSI and TCP model, what is OSI and TCP model and what is comparison of it, and also encapsulation and decapsulation. So, let's start. So, first, OSI model is the Open System Interconnection. OSI model is a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocols. The OSI provides a standard for different computer systems and to be able to communicate with each other. So the TCP and IP model stands for Transmission Control Protocol and Internet Protocol. So TCP is a set of standardized rules that allow computers to communicate on a network such as the Internet. So the difference between the OSI and TCP and comparison. So let's begin first in comparison. So now it's time to compare the reference model that we have learned till now. So let's start by addressing the similarities that both of these models have following similarities. So the first is both have layered architecture. Layers provides similar functionalities. Both are protocol stack and both are reference model. So difference between OSI and TCP reference is the first in Open System Interconnection or OSI is a generic protocol independent standard acting as a communication gateway between network and end user. In TCP Transmission Control Protocol, the first we have is TCP/IP model is based on standard protocols around which the internet has developed. It is communication protocol which allows connection of host over a network. So the second one difference in OSI and TCP is in OSI model, the transport layer guarantees the delivery of packet. In TCP model, the transport layer does not guarantee delivery of a packets. So still the TCP model is more reliable. So in OSI follows vertical approach, in TCP follows horizontal approach. And another one in OSI model, it has a separate presentation layer and session layer. But in TCP, it does not have a separate presentation layer or session layer. And the next one that we have in OSI, transport layer is connection oriented, but in TCP, transport layer is both connection oriented and connectionless. So the next one is in OSI, network layer is both connection oriented and connectionless, but in TCP, network layer is connectionless. So in OSI, it is a reference model around which the network are built. Generally, it is used as a guidance tool. But in TCP IP model, in a way implementation of the OSI model. So the next one that we have in difference between OSI and TCP model is in OSI model, it provides both connection oriented and connectionless service. But in the TCP model, it provides connectionless service. So the next one in OSI model, it defines services, interfaces, and protocols very clearly and makes clear distinction between them. It is protocol independent. But in TCP IP services, the protocols are not clearly separated. It is also protocol dependent. So, and the major difference between OSI model and TCP model, OSI model has 7 layers, but in TCP model, it is has 4 layers. So in the 7 layer in OSI model is application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. But in TCP model, it has only 4 layer. It's called application layer, transport layer, internet layer, and network access layer. So the next thing that we do now is we need to know what is encapsulation and decapsulation, and what are the major difference between those two. So encapsulation, it is a network models are used to standardize network communication when sending data from one location to the other. Data goes through a number of layers. The TCP and IP model has 4 layers. So they are application layer, transport layer, internet layer, and network access layer. So each layer performs a specific role in the TCP and IP model. The application layers are end user services such as email facilities, web browsing, etc. So the transport layer manages the host to a communication in network layer. So the data is known as packets. It provides source and destination IP addresses. So that helps to identify the location in the network. Each device in the network has an IP address. So in network access layer, the packet is called a frame. In this layer, the packet came from the internet layer is given the source and destination MAC addresses. So MAC address is the physical address. Finally, the frame is sent out of the network. So the diagram that encapsulation have is it has have a data, UDP header, UDP data, IP header, IP data, frame header, frame data, and application transport, internet, and link. So encapsulation for short is encapsulation is the process of adding information to the application layer data as it is sent through each model layer. So let's go to what is decapsulation. So decapsulation, as explained in the encapsulation process, the frame goes out of the host computer to the network. So then it reaches the destination host. In the destination host, the frame is decapsulated in the reverse order till the application layer. So the frame which reaches the network access layer contains the data. So TCP and UDP header with IP address and header with MAC addresses. So when it is sent to the network layer, it is a packet and thus data, TCP UDP header, and header with IP address. So then the packet reaches the transport layer. Now it is segment and contains data and TCP UDP header. So now we need to know what is the similarity between encapsulation and decapsulation. So the similarity between encapsulation and decapsulation is it is both encapsulation and decapsulation are related to how the data is sent and received through the networking according to the network models. So now the last one that we need to know is what is the difference between encapsulation and decapsulation. So encapsulation, when the data is moving from upper layer to the lower layer, according to a network model, each layer includes a bundle of information called a header along with the actual data. This packing of data in each layer is known as the encapsulation. So, in decapsulation, when the data is moving from the lower layer to the upper layers, according to the network model, each layer unpacks the corresponding headers and uses the information to obtain the actual data. This unpacking of data in each layer is known as the decapsulation. So the occurrence between encapsulation and decapsulation is encapsulation occurs in the source computer and decapsulation occurs in the destination computer. So that's all for this video. So I hope you learn and enjoy this video. So So, by the way, again, I'm Gutierrez Day. Thank you for watching.